Hello everyone, this video covers mainly section 7.1, which is called integration by parts. We will also cover section 6.5 at the very end, which is a very short section. Now, before we go into integration by parts, let's review what we have done so far when it comes to integration. So far about integration, we have technically done only one, maybe two things. So integration, which remember that's nothing more than antiderivatives. So antiderivatives. So in theory and reality, we have only done one method besides the antiderivatives. And the method is called, I call it substitution. Other books is called a U substitution, because you usually use the letter U to do the substitution. Now, from the U substitution, I told you last class, or the first day of class, from here we get something that are called basic integrals, which everybody should memorize this, and they're gonna make your life pretty useful. These are all based on the U substitution, and the basic integrals are the following. The integral of du over u is equals to ln of u plus c. That's number one. Number two, the integral of the u over 1 plus u squared is equals to tangent inverse u plus c. Number three, and they're not in any particular order of importance, okay? Number three, the integral of e to the u. The u is e to the u, which is probably the easiest one. Number four, the integral of u to the n is equals to u to the n plus 1 over n plus 1. So for example, if you have an integral like this, the integral of, let's say, x cubed, and this was 1 plus x to the 4, you can see that the derivative of this is equals to this. So maybe, just maybe, number one will be the u substitution. Again, this is not new. This is what we done before. We're just reviewing. So in this particular case, you can say, well, let u equals to 1 plus x to the 4. Therefore, that means that the u, it will be 4x cubed dx. So therefore, the integral is now going to be 1/4, the 1/4, because there is no 4 in here. And this will be du. So all of this is the du part over u, and it will give you 1/4 ln, which is this integral of u plus c. But remember, the value for u, the substitution, was equals to 1 plus x to the 4 plus c. And that's it. So this is the substitution method in action, which we have done before, and you were supposed to do this in, again, in calculus 1 multiple times. And it works pretty well as long as the integral is on the right shape. For example, we do one more illustration. Let's say that now you want to integrate the integral of 2x e to the x squared dx. Okay? So now here the substitution is going to be u equals to x squared. Obviously the u is 2x dx, and therefore if we plug it in here, this is going to be e to the u du. Notice that the du has a 2x dx, which is this part, dx 2x. So there's no need to multiply or divide by anything. Now, according to integral number 3 of the basic integrals, therefore this is just equals to e to the u plus c, which in our case this will be e to the x squared, because that was the value for u plus c. And that's it. Okay. So this method is still going to be very useful. We're still going to use it, but it doesn't work in many cases. I'm going to show you an example right when it doesn't work and why then we need a new method, which is going to be the integration by parts. The most basic integral where the substitution doesn't work is the following. So look at this. Let's say you want to integrate x e to the x dx. All right. For this one, substitution won't work. Well, let's see why it won't work. You only have two choices. Choice one for u is that u is equals to e to the x. Notice that the u is again e to the x. So what do you do with the x? So this one will not work. The other choice is you can let, so it will be choice 2. You can say let the u equals to just x, but then the u will be the x. And notice you'll end up with exactly the same problem. So this will not work. So therefore substitution doesn't work. So you need to come up with a different approach. And the method is called integration by parts. And it's actually based on the product rule from calculus 1. So recall the product rule. The product rule says the following: the derivative with respect to x of f times g equals to f prime g plus g prime f. And if we work backwards from this formula, that's how we get the integration by parts. So it's really nothing new. Like I just said in the previous page, if we use the product rule, the derivative with respect to x, let me now make it more formal. It will be equals to f prime of x times g of x plus g prime of x times f of x. Now, remember that the integral is nothing more than the antiderivative. So therefore, if you take now the derivative, the antiderivative on both sides, we'll end up with the following: the f of x times g of x, because these two will cancel each other out, is equals to the integral of f prime of x times g of x plus the integral of g prime of x f of x, and all of these have to have a dx. Now if we rearrange this, then we have if we write this one first, we'll end up with f of x g prime of x dx is going to be equals to f of x g of x minus the integral of g of x times f prime of x dx. Now the key to use this method is you're going to pick two. You have two functions. For one, you're going to take the derivative, and the other one you're going to take the integral to begin with, and then you're going to use the formula. Now, which one you had to integrate and which one you had to differentiate, well, that takes a little bit of practice to realize, but this is after the substitution method, one of the methods you're going to be using the most. Now, this is just a short way to write the formula. So notice that this one will be u, this is the derivative, then this is ub, minus b du. Okay? So all you have to do is identify which one is u, which one is dv, and you should pick u, the one that is easy to take the derivative, and dv, the one that is the easiest one to take the integral. And again, it takes practice to see which one is which. So I'll do a few examples, and the more you practice, the easier this method will become. This is the formula you should memorize whenever we say integration by parts. Okay? And you're going to use it hundreds of times in this class, calculus 3, differential equations, and so forth. Like I say, here u will be f of x, and b will be g of x. So that means that du is f prime of x dx, and dv will be g prime of x dx. All right, so now let's go back to the integral we have in the previous page that we were not able to do with substitution, and now we'll try integration by parts, and you see how it works very nicely. So here u would be x, that will be the first function, and db is going to be whatever is left. So this part will be u, and this will be dv. So in our case, this is e to the x dx. Again, for the first one, you take the derivative, so this will be du, which is clearly just the x. And here b will be the integral of e to the x dx, which is just e to the x plus some constant. Now you don't have to worry about the constant until the very end. So for now, you just write e to the x. That's perfectly fine. So then from here, and I'm going to use this a lot of the time for I, just for integral, whatever is the integral we're dealing with at that point. So in our case, our integral, remember, is going to be ub minus b du. So in our case, u is x, b is e to the x, and then this will be the integral of b, which is e to the x, and du, which happens to be dx. This part is already done, so this is the only one you have to worry about. So this is x e to the x. The integral of e to the x is just e to the x, and then at this point you can put the plus c. Okay. All right. So now in slow motion, this is the ub, and this is the integral of b du. And technically the letter c can go here or it can go here. It doesn't matter. Now you don't have to, but at the very beginning you should do this. So how do we know that this is correct? So just check the answer. So if you take the derivative of x e to the x minus e to the x, you should get this part, okay? Again, it's not necessary. You're not required to check, but you should. So here, notice that with the derivative, this is a product. So you have to use the product rule. It will be 1 times e to the x plus x e to the x. So that's the derivative of this part only. This gives you this. And the derivative of e to the x is just e to the x. Notice that these two cancel, and you end up exactly with e to the x, which is what we have here. So therefore, that clearly proves that the integral of x e to the x, or the antiderivative, is x e to the x minus e to the x plus c. Again, it's not required that you check, but at the beginning you should do it to convince yourselves that you're doing the right thing. All right, so that's the very first example. All right, let's go to the next one. So this one is going to be u, and it's going to be db. If you don't choose the right u and dv, you will find out quickly that you choose the wrong one, and I'll show you what I mean by now after I do it correctly the first time. And remember, it's a good practice to call just the integral just I. So here u will be x, so we already know that the u is just dx, and dv was cosine x dx, which is technically whatever is left. So therefore b is going to be sine x, okay, plus c. But remember, the constant, you can just leave it always to the end. Now remember that the derivative of sine is cosine. This one you take the derivative, and this one you integrate. So then from here, using the formula, it's going to be ub. You should write this a couple times until you get used to, minus b du. U is x, b is sine x, minus b du. Okay? Now the integral of sine x is going to be minus cosine x. So just be careful with this. Why? Because the derivative of cosine is minus sine. So therefore this is going to be minus. So the answer should be x sine x plus cosine x plus c. And that's it. And again, you should check that it's correct by taking the derivative and checking. Now, a very common question here is, how do I choose the right u and the right dv? Again, that takes time, but one thing that you can see right away that is not working is if the problem gets worse. This is what I mean by it gets worse. Let's say that instead of using this for u and this for dv, that you switch the two around. Okay, let's say that you pick u to be cosine. Notice that the u is minus sine, which it was easy to do. And let's say that you pick dv to be x. So therefore b is going to be x squared over 2. Now, if you apply the integral, the ub minus b du, you get the following. This will be x squared over 2 cosine x, then minus and minus is going to be plus, and then this is supposed to have a dx, then this will be sine x times x squared over 2 dx. Notice how this is way worse than when you start with. So that's how you know this was not the right choice. So at this point you should stop and recheck u and dv, because probably that means they are backwards. Okay. And again, it just takes practice to see which one should go first. The rule or the thing you should be looking for is the one you want to integrate should be the easy one, because to take a derivative is not a problem. To take the integral is the issue. So you should pick the easiest one to integrate to be the dv. Let's try the following example, and this will be the perfect case to explain what I meant, that it takes practice to realize which one is which, because it doesn't mean that this always has to be u and this has to be dv. Let's say that we think that's the case and see what happens. So let's say that we pick u to be x squared, and therefore remember dv has to be whatever is left, which is ln x dx. We need du, which is 2x dx. That was easy. But then b is the integral of ln x dx, which is not a basic integral that you know. The derivative of ln x is the x over x, but you don't really know the integral. So this is going to make life difficult. So at this point you realize, okay, since I don't know this, I need to figure out first what it is before I can keep going. Or let me just reverse the choice of U and B, and maybe that will make life easier. So in that case, well, what about we pick U to be ln x? So that means that dv is whatever is left, which is this. That should be x squared dx. Now remember that we know what the derivative of ln x is. It's just 1 over x, or dx over x. And the integral of b is going to be x cubed over 3. All right? So therefore, the integral now, which remember should be ub minus b du, it will be equals to 1/3 x cubed times ln x, which is ub or bu, doesn't matter, minus the integral of b, which in this case, remember, b is equals to x cubed over 3 times du, but du is the x over x. Notice that this simplifies to just 1 over 3 x squared dx, right? So therefore this will be equals to 1/3 x cubed ln x minus 1/3 the integral of x squared dx, and therefore the final answer is going to be 1/3 x cubed ln x minus 1/3 times the integral of x squared, but the integral of x squared is x cubed over 3, then the whole thing plus c. So therefore this is equals to 1/3 x cubed ln x minus 1/9 x cubed plus c. So that's the final answer. Okay. So this was a good choice, or a good way to see you had to rearrange the u and the v sometimes if it doesn't work right away, or if it doesn't work on the first try. Right, let's go to the next example. This is a little bit more tricky, because the way the problem is written is not going to work precisely, so you had to rearrange it, and this is what I mean. Notice the derivative of the derivative with respect to x of x squared plus 4 obviously is just equals to 2x. Okay, why is that important? Because you need to have an x somewhere. Also notice that you take the derivative of x cubed, yeah, you get x squared, but you have the radical, and that's going to make life pretty difficult. So instead, we're going to rearrange it this way before we do the u dv. So notice that's the first thing to notice. That would be number 1, I guess. And number 2, notice that x cubed over the square root of x squared plus 4, you can rewrite it as x squared times x over x squared plus 4. So this is a common trick we're going to use over and over. Okay. Why do we do that? Because now you can see the derivative of this will give you this, except for the 2. So therefore this one is easy to integrate, and this one will be easy to take the derivative. So therefore the integral, we can rewrite it as the integral of x squared times x over the square root of x squared plus 4 dx. Right, so then u will be x squared, and dv will be x over the square root of x squared plus 4 dx. Obviously, the easiest one is the u, which is 2x dx, and b is going to be the integral of x dx over the square root of x squared plus 4. Now, this is what's going to take us back to the very first part where we do the u substitution. So for this one, instead of u, so we don't get confused, let's say that we'd say for this particular, let w is equals to x squared plus 4. So dw will be 2x dx. So therefore from here, b is going to be the integral. We need 1/2 to get rid of these 2 of dw over the square root of w, which is the same thing as the integral of 1/2 of w to the negative 1/2, which we have done this before. And remember that the integral of w to the negative 1/2 is w to the 1/2 times 2 over 1, which is technically just the square root of w. So in our case, b will be just the square root of x squared plus 4, and you can check that that's actually the case. Okay, but again, we're not done. We just found the u and the b. So therefore, the integral is going to be now ub. Okay, let me write again, ub minus b du. U and b is going to be x squared times x squared plus 4. So that's the u and b. So u and b. And then minus b, which we say was this, du, which is the 2x dx. And this part is done. Notice that for this one, you can just use substitution again. And with the substitution, this part, it will be like integrating the square root of x, which remember that will be x to the 3/2 times 2/3. Nothing new if you do the u substitution, so this will be therefore 2/3 x squared plus 4 to the 3/2, and then plus c, and this with the integral. So you can see how this took a lot longer because you had to do substitution twice, which I told you will still have to use substitution, and you had to rewrite it first before you can apply the integration by parts. These are the typical problems that will take the longest because you had to rearrange things before you can even try. Now let's try a problem where we combine integration by parts, and what you learn in 6.1, which is where you had to find the area between two curves or two graphs. So here, if we graph x squared e to the x, so let's say this is f, and this is g, they start in 0, and then the graph of x squared e to the minus x, the graph looks something like this. You should just check using the graphing calculator. It looks something like that. So this will be f of x, and then g of x actually looks like this. Let's see, like this. Obviously they intersect in some point, which we'll check right now. There is actually 1, and it looks like this. And it says find the area bounded by the curves. So in this particular case is this. Therefore the area we follow the same formulas from 6.1, it's going to be the integral of the biggest one, which in this case is x e to the minus x, minus the smallest one, which is going to be x squared e to the minus x dx. Remember, we still need to find the intersection, just like we did before. So for the intersection, you set the two equals to each other. Now, since e to the x is never gonna be 0, you can cancel them out because it will not be 0. So you're not dividing by 0. So therefore you will have this, which means that you can factor it like this, and they will intersect at x equals to 0 and x equals to 1, which is not surprising. That's exactly what we have. Okay. So therefore, to find the area, now you have two integrals, and it will be the biggest minus the small one. Now you can actually do this in several ways. This will be the integral from 0 to 1. You can factor the e to the minus x, and it will be x minus x squared. And then you can use integration by parts here and here, but it's better to have it in two integrals the way we have it originally, which was this, and then minus the integral from 0 to 1 of x squared e to the minus x dx. Now you have to use integration by parts in this one and integration by part in this one twice. So for this part, the u will be x, the dv will be e to the minus x, so therefore du will be the x, and here v will be minus e to the minus x. So to make life easier, or for you to follow, let's just say this part will be integral 1, this will be integral 2. So let's do one at a time. Remember, the answer has to be integral 1 minus integral 2. So for integral 1, this will be ub, which will be this, minus b du. So this is minus x e to the minus x plus the integral of e to the minus x dx, which will be minus x e to the minus x minus e to the minus x from 0 to 1. So notice that if you plug in 1, it will give you minus 1 e to the minus 1 minus e to the minus 1. And then if you plug in 0, it will be 0 minus e to the 0. So this is technically 1 minus 2 e to the minus 1. So that's for integral 1. We still have to do integral 2. And for integral 2, you have to do the integration by parts twice. So that will take a little longer. So you set it up, and then you need to finish this. So for this one, which is a separate problem, we're going to do the same thing. Now u will be x squared, dv will be e to the minus x. So therefore the u will be 2x, and b will be minus e to the minus x. And this is what I mean by you have to do it twice. The first part is going to be now minus 2x e to the minus x, that's ub, minus b du. Okay. So notice that this will be minus 2x e to the minus x, and now this will be plus 2 the integral of x e to the minus x dx, which if you look closely, this is essentially this part. So you can technically just use the the answer from here. So this part is going to be this. And for this part, so you just need to plug the limits of integration. So this is what we have. We have minus 2x e to the minus x, and then plus 2. And then we can just copy this part because it is the same. This same thing as this, right? So then it will be 2 times 1 minus 2e to the minus 1. Well, this one you still have to do 0 to 1. So this will be now minus 2 e to the minus 1. Then if you plug in 0, this will be 0 in here, and then plus 2 minus 4 e to the negative 1. So therefore this is 2 minus 6 e to the negative 1. That's the final answer. Finally, let me just do a quick review of section 6.5. There's really nothing new here. This is just called the average, which is the same thing as the mean. So this is the average value of a function. And the average value of a function, which is usually called f average, is going to be the integral divided by the length of the interval. So if you have a function, any function, let's say this is f of x, and you want to find the average value between a and b, where this is the area which is denoted by the integral, the average is going to be the integral from a to b of f of x dx. So as you can see, there is nothing new. You just find the area and divide by the length of the area, and that will give you the average. So for example, the easiest thing will be we have f of x equals to x squared, and x goes from 0 to 4. So in that case, the average value of the function is going to be 1 over 4 minus 0 times the integral from 0 to 4 of x squared dx, which will be 1/4. Now the integral of x squared is equals to x cubed over 3 from 0 to 4. So therefore this will be 1/4 times 4 cubed over 3 minus 0 cubed over 3. Remember that 4 cubed is 64, and this is 0. So this is technically 16 over 3, and that will be the average value of the function. Now it could be anything where now you may have to use integration by parts. So for example, what will be the average value of x e to the x now from 0 to 2? So then the average value of the function, it will be the integral from 0 to 2 of x e to the x dx. For this, you will need to use now the integral we did, which was x e to the x minus e to the x. Just check the first example we did. This is using integration by parts, and this is from 0 to 2. So in this case it will be 1/2. It will be 2 e to the 2 minus e to the 2 minus 0 e to the 0 minus e to the 0, which is 1. So therefore it will be 2 e to the 2 minus e to the 2. That will be e to the 2, and then minus and minus is plus, so plus 1. That's it. So as you can see, there is nothing special about the average value of the function. Just integrate the area and divide by the length of the interval. By the way, now you can also use integration by parts to find volumes using either cylindrical shells or the washer method. Okay, and that's it.